center pressure, what all various parameters which we can analyze for the study of biomechanical analysis of the ankle joint or knee joint. Which parameters do we need to keep in mind or do we need to focus on more?
I'm not sure if I fully understand the direction of your question. So, which parameters in addition to the ground reactional force?
Yes. Ground reaction force. You mentioned ground reaction force and center pressure. So, like, what more factors? For example, energy consumption or energy dissipation of a particular joint, or power required.
Okay.
Yeah, like that.
Okay, good. So, this is just the introduction to the topic. So, when we talk about the simplified models, the just ground reaction force and center pressure and the three-dimensional motion is a good place to start. But that allows you to then calculate inverse dynamics of the overall structure. So with that, when you calculate the torque about the joint, you can also calculate the power produced by that joint based on how much the torque and how much angular velocity is occurring at the same time. So then with that power estimate, you can also calculate work produced, right? And so this gives us more interpretive value for the joints themselves, not just how much torque is needed to keep me from collapsing, but in dynamic motion, how much energy is absorbed and how much energy is produced from a certain motion. And then if you're designing interventions, like say a better prosthesis or orthosis that yields some energy return, or even a better shoe to yield more energy return, then you can calculate what the standard is for say an ankle power absorption versus production. And then, but it's all still based on the assumptions of the inverse dynamics for that. One way you can improve on some of those things is to complicate the model quite a bit, which is to better understand the soft tissue of the foot structure and of the Achilles tendon. And so then you might be able to do something that's more of a forward dynamics model, where if I have an assumption about how much muscular contraction there is, I can affect the actual motion by simulating this much contraction yields this much tension, which yields this much torque, which then produces that much motion. So you can go at it from so you can either drive the model forward with inputs of force to get the resulting kinematics, or in the clinical gait analysis world, it's often the case you get the motion and the force and calculate back internally joints we're actually doing. So again, both ways. Yes.
Good afternoon. So when we do similar analysis as the one shown in this slide, when a person is wearing a shoe and when a person is not wearing a shoe, the pattern in which the center of pressure moves in the case when a person is wearing a shoe differs from his natural movement. So the variation does that actually say anything on the advantages of wearing a shoe? Like, in other words, does wearing a shoe actually give any advantage, or is it actually only, increasing the area of pressure?
Okay, that's a good question. So yes, if you put this sensor on the ground and walk over it barefoot, you'll have a different reading than if you cut that sensor and put it into the shoe, because it's conforming more to the surface of the insole of the shoe and the interface with your foot. So you're going to get more contact pressure just by the fact that the arch shape of the insole will push up against the foot itself. So the readings themselves will be different already. So it's a little bit complicating in that way. It's not a fair comparison between the shod condition versus barefoot condition. But one of the things that I'm talking about with footwear design is that what is the purpose, what is the function of the shoe itself? Person. So sometimes that can be taken as it's comfortable because to experience what the person wants functionally. So I may have a very comfortable shoe for standing here today, but functionally it's not a very good shoe for running fast or for jumping over a hurdle or something. So I may need a stiffer, less comfortable shoe for that. So a very specific sport function. As far as the function of walking and everyday life, the function of the mechanics of gait, there's very little additional that the shoe provides. because people adapt to it. So if I walk barefoot, I will adapt to avoid those sharp objects, right? The person becomes accustomed to that and adjusts how they walk so it's less careful and more just kind of pushing the world out away from you, right? So shoes, when they go to barefoot condition, they're very careful with how they walk for a while until they become accustomed to how to do that. And similarly, if someone is going from barefoot habitual lifestyle to then putting on these other shoes, they adjust right away to how they walk based on the fact that there's a huge pillow of protection around their foot. So yeah, I don't know if that fully answers your question. I think it's tough to analyze the differences between the two because immediately the human adapts to what that new device is. So I don't know if you can ever get a straight answer about what's best between the two.
Sir, is it reliable to use the motion captured specifically for the animation movies to work on biomechanics, not captured for the biomechanics specifically? Is it reliable? Does it give?
Okay, it's a good question.
Because some reasons we cannot do getting capturing motion capturing due to the expenses and already people have done for the artistic form of dances and they have recorded and they uploaded in their to get the dynamic spot out from that.
So it's a good question about how reliable motion capture can be in the animation studios, essentially. Okay. So animation is art, yeah. So oftentimes, even if you're using the scientific tool to make the data that allows you to produce the art, at some point the artist always adjusts the look to have it be perceived as they want it to look, right? So with that, sometimes we found that animation studios take a little bit of liberty with how they collect the data. So it's very common in animation studios to have the actor come in and put on a full suit that's like a very tight-fitting kind of black suit, right? And it already has markers on it. So those markers are not placed specific to that individual's bony structure. It's just placed on the assumption that arms are about this long and legs are about that long, and there's some joints between them. And we figured out that this works pretty well. So then we don't have to take time to put the markers on for a very specific clinical question. So it's an ease of use a little bit, and it gives very human-like motion, right? It's because the human's still driving the suit, but it doesn't give the accuracy of where the joint location is. So if you were to take animation-based, well, you wouldn't have information about the segment endpoints to be able to calculate what the forces are that cross between those. So yeah, there's some inaccuracies, I think, in how they capture the data. But the trade-off is they're able to get very quick collections. And the other purpose of that is maybe to have multiple people in one space interacting with each other for the movie, right? And so if you have to take the time to put all those markers on very accurately for each of those individuals, the movie budget goes up and up. They're also able to then capture facial motion with a lot of this as well now. That's, I think, where the animation studios have contributed the most back to the science, is they know how many markers are required for the human to stand on for very long at all. That's part of, I think, why we've designed things to cover our feet, is also the comfort of standing on something that's really too rigid to be comfortable on for any length of time, experience the stresses that they're designed for. So then the collagenous structure of the tendons will actually become changed and become less capable of experiencing that force when they do experience it. So there's some evidence to show that if the person is in a very confined environment every day, and then they experience some new injury, they could have sustained that injury if their joints and their tissues were capable of experiencing it. But because they've been constrained to something that's very non-motion, non-stress, non-force crossing that system, they're not capable of adjusting when they need to. So it's kind of a long philosophical discussion we could have about this. So in the end, what type of surface? Probably something that's relatively soft, like a moss surface, over an uneven terrain, because you want something that is not harmful to the surface of your foot, and that you can enjoy standing on for a long time, but also something that provides a lot of variation. So then the foot is constantly having to adjust to what's underneath, and I don't always stand on a completely level surface. How's that? Is that answer your question? So maybe some uneven moss. Yeah. We can design it.
There is another important session in there, the unique session. And one more thing, we have there is a secondary session for journal discussion. In that, whether because our expert is having some journal papers, whether you want in the mail or you want the hard copy, something you want. How you want to discuss? Because the expert is going to discuss about the how to write the maths, like in a journal, how to write a maths, what are things to be taken there. Those things he will discuss because he has some papers. Okay, whether I can circulate as a hard copy or whether you need it through mail, I can send the hard copy. Okay, that's fine. There's a question in the time. It's a time for a